There's 5 applications of derivative. First, to find the rate of change of a variables. Second, to determine increasing and decreasing of a function. Third, to find a relative maximum and minimum point. Fourth, to determine point of reflection. And lastly, to sketch a graph using critical points, horizontal and vertical asymptotes. My name is Cik Adam Danish, metric number F23SP5060. There's a lot of application of derivative in real life. One of it is in this question. So, crude oil from an unused well is diffusing upward in the form of a circular film on the ground's water surface. If the radius of the circular film is increasing at the rate of 1.2 meters per minute, how fast is the area of the oil film spreading at the instant when the radius is 165 meters? So from this question, we know that dr over dt equals to 1.2 meter per minute. So right here, right, rate 1.2 meter per minute. So we want to find dA over dt when the r is 165 meters. So we know that area of a circle is pi r square. If we derive this, we get dA over dr equals to 2 pi r. Now, we must, how to find this? We must use the chain rule. dA over dt equals to dA dt times dr over dt. So now we just put the value inside of this equation. dA over dr is 2 pi r times with dr over dt 1.2. So we have the value of r, which is 165 meters. So 1.2. So just press your calculator. We get dA over dt equals to 396 pi m square per minute.
My name is Nafis, matrix number F23SP5708. So, another application of derivative in real life is a shell, a marketing shell. So, this is an example. A company produces and sells smartphones. The cost function for producing smartphone is, given the function is Cx equals to 5000 plus 50x and 0.02x squared, and x is the number of phones. And another function is the revenue function for selling smartphone, and that is 800x minus 0.05x squared. So the question is how to determine the number of smartphones that should be produced to maximize profit. So to maximize profit, we need to find a point where revenue is maximized and the cost is minimized. And that way is by gathering the function Rx and minus with Cx. So if you just, this is just a basic calculator, so you can do it, there is no problem, I believe there is no problem. So just minus 800x with the same group like 50x, and then the negative 0.05x squared with the 0.02x squared. And then you will get a negative 0.07x squared plus 750x minus 5000. And now, the second step is we need to differentiate the production function. So, to differentiate this function, excuse me, so to differentiate this function, this is also just a basic differentiation. I believe there is no problem. 5000. So this is the px. So first differentiation is 2 should be at front. 2 times with negative 0.07 and you will get 0.14, and minus 1 you will get x. 1 goes to the front, you will get 750 times with 1 and you will get 750, and then x will be removed. And then 5000 with no variable is gone. So this is your first derivative. So moving on, and now, so the after we got our first differentiation derivative, now we need to equal to 0. This function is equal to 0. Why? This is because we need to equal it to 0 to find the critical points, and then determine whether each critical points correspond to the maximum, minimum, or neither. So just put your function back and then equal it to 0, and then find the value of x. X is equals to negative 750 divided by 0.14, and then kick in the calculator, and you will get excuse me, pardon, and then you will get the value of 5357.14, and this should be your final answer. But to prove, and the reason why this should be your final answer is from this is because given that we have our first derivative, right, and then 0.14x minus 750, it is the same with y equals to mx plus c. It is a linear, a straight line. So since since the function of p first derivative x is linear, it is decreasing everywhere. So the critical point at x equals to 5357.14 corresponds to.
My name is Muhammad Arifin, matrix number F23SP5196. Now I will explain how to find the approximate value. The question states that use differentiation to approximate the value of square root of 121.2. It's easy if you want to find square root of 121. It's 11. But with the 0.2, we have to use the approximation method. To start with, let x equals to 121 and dx equals to 0.2. We have to keep those two separate so it's easier for us to differentiate. And then y equals to square root of 121 equals to 11. dy is the thing that we want to find right now to get the final answer. The formula is dy equals to f prime x dx. Okay, now start with fx equals to square root of x. Why square root of x? Because we already stated here. And here. 121 equals to x. Then we differentiate this one first. F prime x equals to 1 over 2 times x power of negative 1 over 2. Then we'll get 1 over 2 times square root of x.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Raib Biru Hisham. Nombor metrik saya F23SP5038.
Okay, now I will explain about the increasing and decreasing topic and maximum and minimum point topic. Okay, I will explain using this equation. So from this equation, first thing first, we must first derivative our equation. So as we know, in increasing, decreasing and maximum minimum point, first derivative will equals to 0. So dy dx equals to 0. We take our first derivative and equals to 0 like this. After we find the critical value, we make a table. Make a table that have two columns. On the top of the two line, we put our critical value, negative 1 and 1. At the left, we put a random number that below the negative 1. Here, we put the number that between the negative 1 and 1. And here, we put a bigger number than 1. So, after we put our random number, we substitute our number, this number, 3 number, into our first derivative, like this.